I want to thank you for giving me this opportunity to present today in this great event. And of course, I have heard a lot today about rain, water, weather, and what I'm going to tell you is my team's research results, what we had during the development of one of the solutions for weather protection. You know, when you have a weather, this is something what we can't as humans influence. And when I see such a building, such a situation in a building, then of course my heart gets broken, and obviously it consequences to a different damages. First of all, the visual damages, and of course, secondly, to structural damages. And it's absolutely clear for everybody that it's rain, sun, temperature is not a friend of the timber constructions. And as you know, as a basis of our working package, what we had to do is we actually had a task to create a solution, a material which could serve the needs of those building phases of the modern timber building, where we have the production, transportation, storage on the site, assembly phase, and a building phase. And it's one of the most important points also was that we were forced to think a little bit more out of the box, and we had to also think how this weather protection would be afterwards transferred or integrated as a functional layer. I will tell you about that in a process of my presentation. So what was the first point? What we started our step one for that product development team was that we had to analyze today's problem and actually today's solution. And what we found out was that, first of all, the buildings with the weather protection are becoming camping sites. Then, of course, there are solutions, but the solutions are becoming basically that this is the only job you can do in a day, is to install it and to remove it. And we don't have any time for any other job to do. And of course, in many cases, we see that the temporary protection of the timber constructions, the cost of this temporary protection is sometimes even higher than the whole building itself. But then we looked into more advanced points. And of course, we saw that actually today there are several solutions existing, and they are mainly used by the wind protection membranes, non-woven fleece membranes with the full area adhesive attached to that. And this full adhesive works as that this membrane is it's possible to attach to the protective surface. In this case, it could be a CLT, but it can also be the different wooden base plates. And then of course it works as a protection material. But normally these materials are being produced for vertical surfaces because the vertical surfaces has possibility for rain to drive down, and of course also the management of the overlap of the membrane is possible, and it works. And then the risk for such constructions are to be damaged by the weather is getting less and less. Obviously, these membranes, they have the composition of the material is that there are normally two protective fleece layers. You can see that's the top layer and the middle layer here. And between those two fleece layers, normally the functional layer, a very thin plastic or microporous layer is being welded in. And then this functional layer is basically protected from the both sides, from the mechanical influences, from the rain, from the UV, etc., etc. And then for all of those three layer composition, there is an adhesive layer connected, and then the material is actually pretty fine for all the vertical surfaces. And it works very good. We have monitored that it has a good functionality and also quite good life length, especially when it's outside exposed in the UV radiation. Either way, these solutions, these membranes, which are made for vertical surfaces, more and more are being used for horizontal surface protection. And of course, because the horizontal surface protection is coming more and more into the need, this protection is demanded from the designers and from the builders. And then we had a look on what is actually going on in these details, because what we have a membrane. We are of course we are having an overlapping, and then there's a rain, but of course the rain don't have a chance to dry or to drive away from the surface. It stays there for certain time until it dries. And of course, when we think of such a composition of the material, then when we look to this detail, we see a risk, especially in the overlap. And when we look to the same detail where we, for example, have mechanical damages or a cut holes or a drilled holes from the building site, then of course all of these three layers in these damaged places are pretty much open. And you know what happens when we put the tissue into the water? We always see a very clear that there's a quite strong capillary movement of the moist. And exactly the same happens in these details. So that by the capillarity, actually the material which we have installed as a protection material is starting to work as a water transportation material. Let me have a look on the on actual building detail. Here you see a balcony where the one CLT element or one timber element is actually working as an inner element, and at some point also the exterior element. And of course we can get on the exterior part the water influence. And then with this transportation capacity, we put under the risk whole surface inside, and we are actually putting the high risk also on the end grain of the load bearing construction. If we think about the damages of this of the membrane by the mechanics, then exactly the same happens. The material is working as a capillary transportation layer, and we definitely are transporting the moist into dangerous points. Yeah, that's what we see quite often in a building sites on overlap details and applications. So our step 2 in this project was pretty simple. We actually had to look what the market demands, what are technical properties we really want to achieve with this future solution. Of course, first and the main important point was the composition of the material have to be built in such an innovative way that this capillary effect is reduced to the minimum. And it's obviously very, very important property to be achieved. Secondly, is the mechanical resistance. And you know, it's not only the people with the boots, it's also the storage of the building elements. it is the mechanical elements, like a scaffold, like mechanical tools, etc. And of course, the weather influence is crucial. What I want to say with that is that this spring we have monitored the project where we had at least 3 times ice on the top of the protection material. And you know how strong ice can be when it gets when the water gets to the ice. What are the inner forces? What can influence the membrane? Of course, then it have to be abrasive and translucent, so that the people shouldn't feel like they are on ice field on the top of the material. And the other thing is, if we are building in a timber, we have tons of different connection joints. We have tons of different drilling points, bracket points, and markings on the elements. And if you don't see them, then of course the efficiency of the building is obviously not working as expected. Then, of course, resistance to the moisture diffusion, because it's clear that there are some moist, the built-in moist, which we are simply building in under the membrane or under the cover, protection cover. And it is very important to have the right properties, basically the ST value, which is providing the capacity for that moist, which is built in, to dry out in a certain period, to basically to secure the timber we have protected. And the other very important point is that, you know, if we are installing one layer, then it is crucially important that this layer in the long term can become as one of the functional layers. With this, I mean that this protection layer serves the protection properties in the beginning or the building phase, but it serves as a vapor control layer properties in a long term when all the rest of the materials are being built on the top of this construction. So and of course, its production has their different tools, their different processes for lifting the elements, and of course this protection, it's a crucial point. This protection have to be able to hold the weight. So we have the production facilities have to be able to use their equipment. For example, this vacuum lifter have to work even the protection layer is installed on the top of the CLT element. So step 3, what we had was to start to really compose, to make the composition of the different materials together and to get to the real touchable samples and the prototypes. And you know, we went direction, quite an interesting direction. We made a protective fleece and a functional layer in one layer. So that layer is basically, it's not composed from 3 different layers. It is simply made out of one, with all the properties needed in. So that was a very, very important achievement, where we could basically, with a long testing period, where we tested a couple of hundreds of different fleece materials, we were able to find and actually to compose this layer. And then what we did, which is a very innovative point, is that we integrated in that fleece layer, we integrated the glue. So the glue is basically pressed in with the pressure. So what we get a homogeneous material without the layers. And if you see here in the glass, then this composition actually is reducing the capillarity effect of this material. Of course, it has a very little, but either way, it reduces it dramatically. So then we of course went for a testing, internal testing. We invented we call it a forklift test. Actually, it's a funny test, but we loaded a forklift at a certain weight, and we were doing a full 180-degree turns with the several repetitions after the outside exposed and UV impact. And then we did several times, and then we monitored how fast we actually get material damaged to the point where we see the timber. Then, of course, we did a moisture management, where we did during a 10-month period, we did a monitoring of timber moist behavior. Of course, it was also that it's in the summer and the winter. Then what was very important point that there was a very detailed test about the standing water on the overlap. And in one of the tests, actually, we were managing hold for a week 10 centimeter standing water. Then, of course, the water tightness of the damaged areas, diffusion capacity. I mean, when we got the timber with the built-in moist, then we were monitoring how this moist is able to diffuse through the protective layer. And of course, then we did the modification of SD value, that we have the sufficient drying capacity. Then we have a sufficient layer for providing the airtight layer, because we then are able to actually define it as a functional layer in the long term. And of course, the vapor control layer function with the many kinds of simulations and build-ups of the different constructions of the solid timber. So yeah, and of course the different lab tests regarding the mechanical strength and artificial aging, where we kind of ensured that that this protection material is really serving all the necessary needs of the protection. And of course, the building site tests, starting in all the stages. We started in the factories, in the CLT factories, where we really monitored how the installation is being done, how fast it is, that it is an easy and enjoyable process, and it doesn't destroy the whole production process. And of course, we also install the material on the different applications, horizontal, vertical, also as a built-in applications. And yes, then according to all that research and development part, we actually came to the conclusions. We have the product, and we know that the normally wind protection membranes can be used and are very fine working with the vertical, but not for the horizontal. With this composition of the product, with the just only basically one layer, it is possible to use it for the vertical, and mainly what is very important also for the horizontal surfaces. It is really working, and it provides the necessary protection of horizontal wooden surfaces in all the stages, really in all the stages of the building. But what we know at the moment, it's clear, already being in several projects, that first of all, the weather protection have to be designed and actually demanded from the builder, and also priced in. Secondly, what we really see is the waste management point. And I think here, with such a innovative material where we are installing it and it stays into the construction, actually we are really we have to think over what is the waste cost of the waste management. Yeah, and that is also a huge benefit for such. Then we have checked in real life that this protective membrane can also work for the element producers, where the elements can be, for example, in this case, the element is produced until this wooden sheet, the wooden sheet is being protected, and the top insulation is being installed afterwards on the site. Of course, the note is that there have to be a special membrane used, but this is just a sample. Then obviously, when we are at the moment, there's a lot of time when we are installing the bitumen as a protective membrane and of course as a vapor control layer. Then this is where the protective membrane can be used for the protective purposes and a functionality. And then afterwards, when we are of course building up the top of the compact roof with the insulation and the final waterproofing material, this material is becoming as a vapor control layer. Thank you.